Oh, and finally, we're on the last types. There's a lot of information in here. So the last thing we're going to do is name acids, and then we're going to just quickly throw in diatomic elements. So when we're naming acids, there are two types of acids. The first one are ones that don't contain oxygen, and the second one are ones that do contain oxygen. So it's always the anion or the negatively charged polyatomic ion or just ion that is going to contain or not contain the oxygen. Let's start with anions that do not contain oxygen. When you're naming an acid that doesn't contain an oxygen, you replace the hydrogen with just hydro, right? And again, everybody should know that an acid has to have hydrogen, right? Because acids are proton donors, meaning they give up their hydrogen. So when you're having an acid like HF, if it doesn't have an oxygen, you replace hydrogen with hydro, and then you change the ending of your anion to ic, and then add the word acid. So HF would be hydro, and then fluoric acid. H2S would be hydro sulfuric acid. All right, let's try a few. So let's try ones that are hydro. So if we start with a hydro, we know that this is going to be an acid without an oxygen. So hydrobromic acid is going to be hydrogen, which is always a +1 charge as a cation. And then we're going to look up bromine. So bromine, not in that list, so we have to go back up here. I'm going to pass through here, so why don't we go bromine is 35. Rotate. 35 is over here. Bromine is a -1 charge. So this is going to be HBr. And something I haven't done in the key, but I'm just going to mention here, is that acids are always aqueous. So if you're ever wondering the state of an acid, you could always put the aqueous after. Okay, try hydrotelluric. Right, so I'm going to look up tellurium. There it is. So tellurium is -2 when it's acting as the anion. It was Te, right? Yep. Okay, so it's going to be HTE, so I'm going to put H2Te, and that's going to be hydrotelluric. If I was going to name these, again, I'm looking at the fact that there's no oxygen, so I'm just going to say it's hydro. And then this one is iodine, so it's going to be iodic acid. This one, again, no oxygen, so I'm going to start it with hydro. And then this is selenium, so it's going to be selenic acid. So when there's no oxygen, pretty simple. Start with hydro, end in ic acid. All right, let's make it more complicated. So let's go on to our oxyacids. Our oxyacids are acids that contain oxygen. So the anion is going to contain an oxygen. The nice thing is we get to drop the hydrogen. So the hydrogen we do not reference in the name. We just name it after the anion. Here's the hard part. If the anion ends in an ite, then you change the ending to us and put acid. So for example, NO2, if we look at our information booklet, so much scrolling. If we look here and then rotating. If we look over here, I've forgotten what we're looking up. If we are looking up NO2, so we go down here to NO2, see how it's nitrite? For the acid, we're going to change the ending ite to us and put acid. So if we look at HNO2, it would be nitrous acid because it was a hydrogen and a nitrite. If the ending is an ate, something like nitrate, NO3, you would change the ending to nitric acid. So again, drop the hydrogen, ate goes to ic, and put acid. There's this little saying that kind of goes with it. So I ate it, and it was icky, right? And then the other one is I took a bite, and it was humongous. that's how it goes. That's how I remember it anyway. Okay, so I took a bite and it was humongous. A picture like really expanding your mouth versus I ate it and it was icky. I was just looking up quickly if there's any other ones. Those are the only ones I've ever known. There's a whole thing about, whether there's more oxygens or less oxygens, but that requires a lot of knowledge. So I'm just going to stick with, I took a bite and it was humongous. I ate it and it was icky. I don't know. Or write it down somewhere. So let's try some. So we are going to write the formula of these oxyacids. So again, it ends in acid, but there's no hydro to start. So I know I'm talking about an oxygen-containing polyatomic ion that is part of my acid. So if I'm looking at nitric, ic goes to 8. So this would be nitrate, which I don't need to write down, nitrate, which is NO3. So if we go to our information booklet, I look up nitrate, it's NO3, and NO3 has a -1 charge. Then I know because it's an acid, it's going to start with hydrogen. Hydrogen is always +1, so these are balanced for charge, and we would just say HNO3. Nitrous, so us, goes with I took a bite, so I know this is going to be nitrite. So then I go to my information booklet, I look at nitrite. Nitrite is the one that has less oxygens. So it's going to be NO2 with still a -1 charge. So it's going to be NO2 minus combining with that hydrogen plus, and the formula would be HNO2. Then we move on to carbonic. Again, carbonic, I ate it and it was icky. So I'm looking at carbonate. When I look for carbonate, sorry, my thing just moved. If I look for carbonate, it's CO3 2 minus, CO3 2 minus with that hydrogen plus. So then I have to do the crisscross and I get 2 hydrogens combining with the carbonate. So we would have H2CO3. All right, then lastly, we're going to name some. So I need to look up what this is. I'm just going to quickly put that tab back with everything else. There we go. Okay, so we're going to look up C2H3O2. C2H3O2. All right, so we are going to look up C2H3O2. Sorry, I got distracted by my child. When you come to your polyatomic anion, when we look for C2H3O2, it is not going to be apparent that it's there, okay? So what you have to realize is that just because something is written like that doesn't mean it can't be split up. So I was going to rewrite this one differently, but I was like, you know what? It's actually kind of a good lesson to see that things can appear a little bit differently. If you look on this formula sheet over here, you've got CH3COO. You have C2H3O2 minus. Okay, so just be aware, sometimes it won't appear exactly, and it's really only this one that they do that with, but it can be written as C2H3O2, but more often it's written as CH3COO. What we want to know is that it has a -1 charge, and that it's called either ethanoate or acetate, and more often it's going to be called acetate. So let's go back to our note, and we're going to call this acetate. Now, again, it's oxygen containing, so the 8, I ate it and it was icky. You're going to call this acetic acid. Okay, this one, this is phosphate. I ate it and it was icky. So this is going to be I actually had to pause the video there for a sec, so I was like having a brain fart. I'm like, it's not phosphoric acid. You have to know that it's actually phosphoric acid. So nothing's ever cut and dry. Nothing's ever as simple as it seems. But when you see enough of these, you'll never see a phosphoric acid. And so we are going to call this one phosphoric acid. So again, we looked up PO4, it was phosphate, but then we changed it. And same thing with like sulfate becomes sulfuric acid. There are a couple things that I'm realizing are not entirely included in here. Yeah, so just be aware of that. But you do enough chemistry and you're like, oh yeah, okay, it's just one of those ones. Okay, so then last one we're going to look at is NO2. I've got my NO2, which is my nitrite. So this is nitrite. I took a bite and it was humongous. So then this is going to be nitrous acid. Sweet. The last part of this video is just about diatomics. It'll just take us 2 seconds. Just realizing that when you're writing the chemical formula or for the compounds, including our diatomic molecules, is that you have to have 2 of them. So diatomic means 2, di. And what it is that some of your gas elements never occur in nature as a lone atom. So if you're ever looking at, a reaction where they give everything in words and they include one of these diatomic molecules, that you always have to put them with a subscript 2. So there's a couple ways of remembering which gas elements are your diatomics. There's this little saying, have no fear of ice cold beer. So it's hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. I like thinking of H and off and down. So what I mean by that is it's hydrogen, nitrogen, oxygen, fluorine, and down, chlorine, bromine, iodine, and what is that, astenine or something? Is that what that one's called? Yeah, it is acetylene. So you go down there. So it's just the one at the bottom that's not included. So the reason I like H and off and down is because I don't have to remember a rhyme. I can just memorize that positioning on the periodic table. And if I ever see them, I know those are my diatomics. So for example, if I told you to write the compound for the diatomic compound chlorine, because I look at chlorine and I say, oh, it's one of my diatomics, you would write it as a chlorine. Bromine, this is a diatomic, it's written as a diatomic. Now the naming, you simply just write bromine. There's nothing fancy. So when you're having a reaction, sometimes you will have a single element in your reaction, and just be careful if it is one of your diatomics. Whew. All right, so now go and practice the rest of your naming. So there's a little bit of practice on acids. I didn't put any mini practice on diatomics, but then at the end, number 23 and number 24 is all of your naming rules combined. So if you were going to do something bare minimum at this point, you're going to do number 23 and 24 and see if you can name them all correctly. Awesome. Good luck.